Hello everyone, welcome to my Cat in Cafe. In this section, I would like to demonstrate on how to create the drainage work in Revit. Additionally, I will be using Dynamo for further productivity purpose. By the way, my name is Ong. So in this section, I try to break down into 5 parts. The first one will be overall overview. Then later on, I will explain on what kind of requirements do we need it. Then what kind of workflow do we have to follow up. Then later on, I will demonstrate on how to create the drainage work step by step in Revit and together with Excel as well. And finally, we will conclude this section. Okay, so as an overview, the drainage work is kind of the most collaborative work between the engineers and modeler. So it is not a one-time job. So initially, any engineer is supposed to come out the schematic, routine diagram line. Then later on, modeler will provide the drainage. Then later on, engineer will calculate the drainage works. Then later on, that information will be back to the modeler to update on their model. So maybe some point of time there might have some modifications or some revise things on the drainage works as well, so that a lot of repetitions and a lot of changes have to be happen. So yeah, it's kind of, so basically I already explained it. You will provide the drainage routine diagrams, then they will provide the drainage size so that a modeler can create a model. So this is the way that we work together to come out the probable drainage works. So in general, Revit doesn't have the tools to create the drainage works directly. So we have to think of alternative way to create this to be done. So that in this section, I will be using structural framing family for drain and structural column for the sum to get the proper outcome, to get the proper result as well. So additionally, I will be using Dynamo Add-in to interoperate or exchange information between Revit and Excel. So come to the requirements, then we have to break down into 4 parts: the software, the families, Dynamo code, and spreadsheet as well. So as a software, we need to have the Revit 2017.2 and above. Then we need to have the Dynamo 1.3.3 and above as well. Then additionally, we need to have the additional package like data shapes and bakery for Dynamo as well. So these packages are quite important for us to create the Dynamo code. Then the last one will be the Microsoft Excel. The one also we need it. Engineer also use it. Then as a modeler and drafter also we use it. Then come to the family. Then we should have the drain and sum model family and drain and sum tagging annotation family as well. To let these 2 types of model families and tag family, these 2 families, when we try to let them communicate, then we need share parameter. Without share parameter, these model families and tag families will not communicate very well. So okay, come to the Revit, then you can see that we have the drain family, model family, then this is the sum model family, and this is the drain annotation tag. The drain has two ends, start and end, and even the middle is just to show the marking as well. Then the last one would be the annotation tag for the sum. So we need to have this the family, and later on we need to have two, actually not two, three Dynamo codes. Okay, in this case we just leave it as two Dynamo codes. One is to export to Excel one, another one is import from Excel. The last one will be a spreadsheet. So in this process we need one Excel file, something like need to have this Excel file. So there's a format that we need it. So here is information, some information we will extract out from the Revit, and some information we will be edit in Excel, and we will update back to the Revit as well. So we need this spreadsheet, at least this format. Okay, save there. Okay, then okay, the next one would be the workflow. Okay, so workflow is some like initially drain routine diagram will be decided by the senior engineers or engineer, because they are the one who knows where to discharge out, then how many discharge point do we need, then what kind of routine diagram do we have it, do we need to have it, so that the routine diagram will be decided and created by the senior engineers or engineer. After routine diagram is settled, then we have to come out the catchment area layout. The sample is something like that. This is the catchment area and discharge plan. This is showing as an example. So in this project we have a 3 discharge point. 1 is here, 2 is here, 3 is there. So according to that, then we have to come out the catchment area for each drains. Then after that we have to come out the table for all the drains and their catchment, then their information as well. So this drawing is part of the drainage summation as well. After we finish this, then engineer will calculate in their spreadsheet. This is the sample of their spreadsheet. So whatever information, those catchment area and kind of runoff coefficients or some kind of information will be provided in their spreadsheet. Then finally we will get the invert level or top level kind of drainage information. Then this information will be back to the our drainage drawings or model. Then finally modeler or drafter will produce the drainage drawings or drainage sheets. This is the sample. So after catchment area layout is created, then engineer can easily do the design calculation, drain design calculation. Later on, based on that calculation result, then modeler or drafter will produce the drainage works and drainage schedule as well. Then at the same time we will be doing the coordinations and modification works for the drainage. So the next would be the step-by-step to create the drainage works. So first of all we have to open the drainage layout project, then later on we will load up the family. Okay, we just go to the Revit and have a look at it. Okay, firstly we have to create the drainage file. So I'll be using the default template from the Revit. Then second thing is go to the south. So for drainage layout project, we don't need 2 levels, so just keep it 1 levels and the rest will be throw. Then later on we have to set the level 1 elevations. So to do that, go to visibility and Revit. Then we have to switch on the project base point. Then elevation value we change to, okay, for example 104000. So this is the reduced level. Okay, we make sure to save this file as drainage works 1, for example. So we already changed our elevation to be 104000, but our value haven't changed yet. So to do that, select the level, then go and change the reference, actually elevation base reference to survey point, then things will automatically change. Okay, so now we go back to the site plans. Site plans or level 1 is nearly same, so make sure to choose the site plan will be the best. Then we save again. Now the first step that we are going to load our family. So insert, load family, then we have to select all of it and load it. So things come to here. So family, we have a structure column, structure framing, then we can see some under structure columns and drain under structural framing. So now we're going to model some drains on the project. So click the bin, choose the size, then we have to bring it down before we draw. Then we have ability to choose whether is it an open drains or cover drain. In this case we'll be using the cover drain, so check the cover. Then we will be choosing the arrow direction as well to know our drain where to head, where to be heading. So for example, like this case, when we draw this, you can see that this is a drain, then this arrow is showing that our drain is heading to where, so that we will know that this is the start point, then this is the end point. So the next, then so because of we have choose the structural framing as a drain, that's why all the finishings and joints are quite nice. Okay, so if you want to have the curve also easy to use it, then yeah, something like that. So we have done a few 1 2 3 4 5 6 7, for example, right? So we have the 7 drains, so those elevation we just move it far away, no problem. Okay, so now we have the drain. Some drain we already created. Then one thing we need to know is that when you select one of the drain, then we can see all the informations here. So this information is quite important. This is reference level. So reference level, our reference level is level 1 and the value is 104.104000. So currently is not. So what we need to do is we have to select all of it, then we have to change this reference level to be 104000. Actually we can use we can create one Dynamo code to get this value as well if you want it. But for this time being, we just make it manually. Okay, so now reference level all selected, but come to the top level, and top level means start top level and end top level are still varies. Actually it's supposed to be maybe 104 or some value if there is up and down, but in this case we just leave it that way first. So roughly we have done the schematic diagram for the drain. So now what we need to do is we have to give the name for the drains. So we will give this one as a L1-1. This one will be L1-2. This one will be L1-3. Come to this one, we'll make it L2-1. This one L2-2, and this one will be L3-1, and this one will be L3-2. But one thing I would like to highlight is that when drains are going to be carved, then we won't see this direction marks. So just to highlight is that even we show the drain this arrow, but doesn't appear on the curve. Just bear in mind that. Okay, now we have the drain marking for each drain, so that the next step, okay, what we can do is like we already load the family, then we model the drain, then now we try to create a schedule. So come back to Revit, then go to view, then select the schedule, choose the structural framing, okay, because in this workflow I try not to put the sum in along the drain. If we want to provide it, we can provide it later on. So for this time here, I just leave it as a drain itself. Then now we're going to create the drainage schedule. So what we need to do is we have to choose the mark to be in, then drain length to be in, drain slope to be in, then start this tree information to be in, and this tree information to be in. So that's all. Over here what we need to do is we have to rearrange. Top come first, later on invert level, then the last will be the drain depth. Okay, this way. Then later on we click OK. Then we can have the draft schedule. So in this draft schedule, then we need to adjust, we need to modify some format. So come to format, then select all the length, like either levels or length, or change alignment to be right. Then later on the length also we want it to be meter, and make it 3 decimal place will do. The rest also we will do the same thing. Okay, this is the last one. Then we have to change the unit to be meter and decimal place to be 3. Then click OK. Then click OK. Then all will come to the right place. Only the drain slope is not yet. So slab slope, then put it at the middle. So we still leave it the drain slope to be like this. Okay, so now we have the drainage schedule. So come to the PowerPoint slide. Then what we need to do is we have to update the start and end top level according to the reference level. Means currently our reference level is 104,000, but our top level reference level, top level and end top level is still not that. So what we need to do is we have to run the code. This is a code, very simple code, to update this top end, start top and end top elevation value. So run this, then this value will automatically change to the reference level, because of currently our reference, like our drain top levels are exactly same as the reference level. If our drain tops, for example, like all of our drain tops, maybe like okay, all of it, our drain tops is not at 0, maybe they may have minus 200 for example. If minus 200, then normally what we need to do is we have to come here and we have to minus 200 from the reference level, and we will get the start and end top level value, right? So if we use this code, then this code will easily update according to that changes. So now all drains are offset minus 200 from the reference level. So what we need to do is, we don't need to calculate and type it one by one. What we need to do, we have to run the code. Sometimes not all of the drains are offset equally. Some are 200, some are 100, based on the geographical condition. So the point of time, if we go and update one by one, would be terrible, because drain is not just one drain, two drain, maybe a lot. Then this is where Dynamo code is working. So come to here, let this code to run, then values are automatically updated. Okay, now I will show you that. Okay, now this one, we will make it 0 to 100, means top level will be slope slightly, come to second again will be 100 to 200, and this one will be maybe 200 to 300. This one will be like all will be minus 300 for example. Then the rest also we will make it or to be minus 300. If things happen, normally we have to go there and calculate one by one to get the correct value, right? But in this case, what we need to do is, as a Dynamo, then when we run it, then Dynamo will automatically know how to do it, because in Dynamo we try to put the formula, and that formula is just like that only. We try to extract the start offset and end offset value, then we have to get the main reference, then we minus off and get it done. That's why this is the top. This is the top reference, means that this is the not top. This is the reference level value. So this is a reference level value. Then we have to plus with the offset value. If offset value is minus, then automatically the value will be reduced. Then this value will be updated on our drain top level and invert level. This is the way that we created this code. That's why whenever value change, we don't need to worry about it, we just run it. For example, like now, value or the top start top level and end top levels are now updated based on the model information. So now this model information, we try to change back all to be 0, 0. There is no offset. Then we run again, then value will be back to normal. Okay, so this is it for this code and this update process. Later on, we try to run the second code to export drainage information to the Excel. So come to Revit again, so we don't need to see this view, so just close it off, come to here, right? Then we need to know where to overwrite or save our Revit information. So we need to know is, first thing we have to create a file. This file we save it as, then this format we keep it because this one we already put the formula to generate the drainage works. Whatever this value later will be overridden. Okay, so just leave it here first. Then we have the second the first code called export drain information to the Excel. This file we need to know where we save, right? So what we need to do is we have to run the code. When end user run the code, what user needs to know is that where is this file. Then go and path this file, then sheet name. That's why we still switch on this Excel file. So this sheet name should be exactly same as Excel sheet name. So it should be same as, if this one is 2, then this one also should be 2. This is case sensitive, so have to be very careful. Then the third one will be the start row. Our information started from this row. So this row we count from 0, 1, 2, 3, mean this row number will be 4. So we have to put it 4. Then we have to start the column number, same thing. Our information started from this cell. So the column number is 1. Whatever they will follow up. Then second is column, this column number is for the start top level. Start top level is column number 5, so we choose 5. Then end top level is column number 8, so we make it 8. Then we have to click set value. So whatever information over here, like this information, this information, this information, and these two informations are automatically transferred from Revit to the Excel. So as an engineer, they do not need to remeasure the length or type the reference level and so on and so forth. Things already here. Starting point, this is the submit point. We can say that the drain depth is decided by the engineer, so we have to key in this. Then after that, this value will be automatically come out. When this value is automatically come out based on this slope and this length, then this invert level will be come out as well. So when this end invert level comes out, then this drain depth will be come out. When this drain depth will be come out, then the next drain start depth will be same as the previous drain and depth, right? This is kind of a relationship. So this is the way that we created. So what we need to do is we select this, copy, then we just paste it there, copy, and paste it there. If we have the separate drain group with the submit point, then we have to select this group of information, then paste it, and we can keep continue. So this way, right? So currently, okay, all base drop. Base drop means sometimes drain will be purposely dropped because of some reason. So currently we just still leave it as 0. Then let's see that. Okay, now in this Excel spreadsheet, then we can change the slope as well. So for example, this one will be 300, 300, 300. Then this one we make it 200, 200. Then this one will be 250, 250, for example. Then based on the slope, then drain depth and invert level will be changed. So this is the way that we create it. After that, we finish, then we save it. Then this information we need to get update onto the our Revit information as well. So to do that, then we have to run the input drainage info from Excel. So run this code, then same thing, the Excel file path, we have to select this file, then sheet name have to be same as Excel sheet name, then start row number is from the 4, then slope columns is 3, start invert level is 6, then start drain depth is 7, and drain invert is 9, then end drain depth is 10. After we key in the correct column, means those information will be extracted out and updated on the Revit. So when we set, then this information will be updated accordingly. So this is the way that we create for the drainage works. So after that, we have to go back to our drainage layout. So this is a drainage layout. Then what we need to do is we have to tag the annotation, then finish off this drainage works. So to do that, what we need to do is select the drain, then go to the annotations, then we have this time we have to choose the drain beam annotation. Those beam annotation, we will use this one only all beams in current plan. We select the current plan will do. Then in plan start, we have to choose the structural framing tag, then choose the start. Now false, the one will be the drain mark start, and okay. Then come to the end, so we have to select the drain mark for end. Okay. Normally, normal framing tag, we cannot choose that kind of start or end one. If we want to choose, okay, I will explain it this one later on. Then this one is, I will put it like L first, because under this family we have two types. One is direction L, one is direction R. It's based on that. Then okay, then okay. And you can see all the drains will be appear, because but over here, what value? This value because of I think is something over here. Okay, this one we don't need it, just put it now. I do. So this is the elevations of the beam, so we don't need it. Okay, so now already been on, then just delete away. Actually we don't need to show that one the first place. Okay, so now it's like that. So now here we can see that start, then come to the end, right? Two informations are there. Sometimes there is a drop, then we will put two information. If not, then one information can be taken out. Same thing can be taken out. Same thing can be taken out. Same thing can be taken out. Then come to here, like can be taken out. Same thing. This one is coming. Hey, sorry. This one leave it there. This one take out. This one take out. This one we just move it a bit further. Okay, then this away, right? So sometimes the direction is correct, sometimes this direction not correct. So at the time we have to select, then change to direction R, then we will get the right direction. So it's the same thing, this one is wrong, so we have to choose to the other direction. The one have to change it manually. This one is the same thing. Okay, this one also same thing. Okay, this one also same thing again, make it R. So this is the way that we create the drainage works. Okay, in case of something changed, then this will be automatically updated. Now I will explain why this tagging will appear on the left and information will appear on the end. Is because of when you select and edit it, then from this point, because of this framing tag, we have to have a option to choose it either from start or middle or end. This is where we choose it. So sometimes when you tag to the beams, then your tagging is not goes to the middle, means when they create this family at the first place, then they choose the attach point to be start. That's why things goes to start. Some tagging goes to end because this family is for the endpoint. Attach point is different. So this one is for the tagging. Yeah. Then whatever information is same as the share parameter from the drainage model family. That's why information will be extracted correctly in the project. Oh no, just pick it. Nobody. Cancel. Nobody. So there we go. If we don't want the drain to be covered, then we just uncheck it instantly, so we don't need to worry about it. If we don't want to see this arrow also, we can just uncheck the arrow direction, but good thing is just leave it arrow direction, so in case then we will know. Sometimes this tagging, the direction in the tagging is not actually not so correct. Sometimes it's on the other side, so that this is the right direction that showing on the drawing, so we will know straight away. Okay, this is kind of like the simple drainage works. So now we're going to change something. For example, like this drain will be somewhere there. This drain we're trying to adjust it because of some reason, then we fill it again, for example. Then this drain also we're trying to move it up, then join, fine. Then this one we just okay, this one no choice, we have to connect to that. Then this one also we're trying to move it further away. Then all the informations are out. For example, like this one thing. Okay, means this one's supposed to follow, why no follow? Anyway, we can tag it easily later on, right? Or maybe we select this, all of it, then delete away, select all of it, delete away, and almost all of them are gone. Then what we need to do is select this one, go to the annotation tag, then this time end tagging we don't use it, then okay, oh, okay. Then what we need to do is that we have to select all of it to get this annotation. Okay, so there we go, we can have it. Then come to this point, then we need the end also. Then what we need to do is we have to choose the end type for this particular drain only. I don't know why. Okay, then select this one, go to the annotations, then okay, there we go. Oops, why? Yeah, I will take it this one. We can have the like this one, then we can put it manually as well. We're supposed to have the right layer, I don't know why. Okay, anyway, we will see it. Okay, annotations, then okay, and now we will remove it, setting. Then this one I will check it, all of it, then only this one. Then for end, what we need to do is just tagging, we do come to here, rather than structure framing, then we use the N. Okay, there we go. Okay, now this tagging is updated there, but only the thing is this direction is not up to our drain direction, so we have to manually change later on. Now because of these changes, we have to update on our Excel. So go to the schedule. Okay, this drain length will be changed. So what we need to do is we have to open this Excel file, leave it there. We have to run the code to export it again. Export this information. So export, then sheet 1. Okay, so hold on. Then we have to select this file again. Then start row will be row 4. Then column will be 1. Then this one will be 5 and 8. There you go, 5 and 8. And that information will be updated, set. Then when that informations are updated, then this whatever formula those value at the cell will be automatically updated. So after that we save it. Then later on we have to bring back, currently the value will be here. Then this point, for example, like we will have some base draw at the drain number 2, maybe 100. Then drain number 3 also we have another drop, maybe 100 for example. So when 100, then what happened is that this drain depth L3-1 drain depth will be 100 deeper than the previous drain depth. So okay, this is the way that we generate it. Then we save it. Then later on we have to run another code to import back information to the Revit. So row number is 4, slope stays same, so 3. Eval level for start is 6. Drain depth for start point is 7. Drain eval level for endpoint is 9. Then drain depth for endpoint is 10. Then we set. Then information will be updated accordingly. Then based on that, then our drain, we can see that come to 3D must be block before. Okay, so we can have this. So drain over here, this point, then our drain is dropped by 100. Then another case is here, we might have another drop 100 over here. It's automatically captured. Okay, so this is the way that we quickly update our drainage model based on the Excel calculation results, or we can quickly get updated our drainage model information to the Excel as well. So come to the conclusions. Then in this process, we easy to create a model, easy to model the drainage works. Then second thing is easy to extract the drainage information for engineer to calculate the calculation process. Then we can get updated based on the engineering spreadsheet, or either based on our model updated information as well. And lastly, I would like to share about the code that I created. So this time I will show you these two code. One is export to Excel. So what we did is that this group is mainly to create the user input. That's why when we run the code, then there will be the dialog box came out to let end user to provide the Excel file path, sheet names, and row number and column number, even start column number, start top level and top level. That one is because of this group of code. Then from there, then we have to provide the information over here. So basically here, this is the starting point. We have to select the category, structural framing. From there, then we have to filter out those drain. Their mark includes L only. We will select. We try to select. So after that, this selection will become out. All the selections of the drains are their mark includes only L. That's why when we put a drain name, we put a L1, L2, L3. So L is the one that control. If we put a C, then we will not select any drain over here because it's out of selection. After that, we even sort based on our drain mark as well, so that our drain mark will appear as a L1-1, L1-2, L1-3, L2-1, L2-2, L2-3, something like that. After we get the drain, then this drain, from the drain, then we try to get the information like drain top, like drain length, drain slope, drain top level, and drain start top level, and drain end top level. We try to extract out using this code. Then first three, like drain length and drain mark, drain length, and drain slope, this three goes to the first group of Excel export, like write to Excel. The second one, because of our Excel is not continuously. If continuously, then we don't need to split into three group, one enough. But this point we have some information at the middle that like information is breaking down. That's why we try to split into three group. One group is to extract this information. This is for one group. The second group to extract this information. The third group to extract this information. And this three information will be exported to the Excel. Then this Excel file will get updated. That's it. Second code is a bit complicated. Second code is this code. Okay, this is the second code. So basically this blue color one is for the user input only. Whatever we import, we type it in, will be come out to fill up information into the code. So firstly, same thing, what we need to do is here we have to extract the information from the Excel. From there we have to break it down into pieces, like which column we extract, 1, 2, 3, 4, something like that. So whatever information we type it in will be extracted by using this bakery notes. So then from the Revit, we have to come out the selection. This is the selections of the element that we try to get the updated information from the Excel. Then finally we try to set information from the Excel to the Revit. So this is it. This is a user input. This is the Excel data extraction. Then this is the group of element to be selected. Then from there we try to match and get the information from the Excel. Then after value came out, then we try to set value to the selected elements. This is it. Okay, that's all guys, and thank you very much for watching. Then I will see you in next video. Bye bye.